day everyone, this is Engineer Formaliza. Welcome sa ating lecture for today. Okay, so ngayon nasa combinational logic circuits pa rin tayo and we are already done with our magnitude comparators. Ang pag-uusapan naman natin ngayon is yung ating iba pang mga combinational logic circuits which are the encoders and decoders tsaka yung multiplexers and demultiplexers. And we're gonna review again later paano ba mag-design ng iba pang mga combinational logic circuit. But when we discussed magnitude comparator, nabigyan ko na kayo ng glimpse on how to or what are the procedures in designing a combinational logic circuit. Okay, so for now, let's focus dito sa ating encoders and decoders. So ano ba yung encoders and decoders natin? Let's start with decoders. Decoders are also combinational logic circuit that converts n bits of binary information to a maximum of 2 raised to n unique output lines. So ito yung ating decoder. From n number of input lines to 2 raised to n output lines. This have a wide variety of applications. If you are gonna dive deeper into logic circuits in digital circuits, you will see that yung mga decoders natin are applied. Ilan sa mga applications nito, nandyan yung multiplexers natin and demultiplexers. In our digital displays, the 7-segment display, so this uses decoders. Our digital to analog converters, even memory addressing ng ating mga digital circuits. And marami pang iba, marami pang applications ito. Okay? Here, in this circuit, you will see this is what we call a 3 to 8 line decoder. Bakit? This is our input side, and you will see there are 3 variables, A, B, and C. And ang output nito is 2 raised to n. So here we have n is 3. So ang output side natin, ito. Output side, this is 2 raised to n, which is 8. So you will see here that is starting from D0, D1, D2, D3 up to D7. That's a total of 8 outputs. Take note that each of the output lines represents one of the minterms generated from these variables. Okay, so mapapansin nyo dito sa output, what we call this, sa kanyang truth table, mapapansin nyo na yung output niya is isa lang yung naglo-logic high dun sa 8 outputs niya. Okay, but there are other multiple applications where this decoder may be used. So as you can see here, pagka yung ating input is 0, 0, 0, yung D sub 0 lang yung logic high. So 0, 0, 1 yung logic 1, yung D1 naman. 0, 1, 0, D2, 0, 1, 1, D3, and up to 1, 1, 1 ang mag-high naman is D7. Okay, so madami pa, 3 to 8. It can also be 4 to 16 line decoder, 2 to 4 line decoder. So that is our decoder circuit. So the best way to study decoders is by applying this in our through application. Okay, so for example, we are gonna implement this Boolean expression f of a, b, c, whereas the minterms are 1, 3, 5, and 6. And we're gonna try to make a logic circuit using a decoder. So instead of using the logic gates pa isa-isa, we're gonna try to implement this using a decoder. Okay, kasi yung decoder naka-IC na yan. So we can have an IC na decoder. Okay, so depende. Pwedeng 2, 3, 4, 5, 6, about 12 pins. Actually, dapat parang 7, no? Para 3 is to 8. So 1, 2, 3, 4, 5, 6, 7. So 11, 3 to 3 by 8, so 11. Tapos meron syempre yan ground, 12. VCC niyan is 13. And then may isa yan na unused pin. So probably mga 14 pins na AC ito. Okay, so bakit natin na-discuss ito? Kasi baka lang, di ba, sa application is wala kang logic gates na mga ICs, but rather meron ka is a decoder IC. You can use that to implement a certain Boolean function. So how do we do this? Syempre, so we know this is our ito yung nasa loob ng ating logic or ng ating decoder, di ba? Simple 3 to 8 decoder. Kung naka-IC yan, ito yung laman ng IC sa loob. Now, since this is a 3-variable Boolean expression, ibig sabihin, our input will also be 3 and our output will be 8. So it is safe to say that we are gonna use a 3 to 8 decoder. Okay? We can also see here that in-express niya yung function niya in terms of the min terms. So when we know the min terms, we can get the sum of product form. Tama? So we can simply OR yung mga decoder outputs. Bakit? Etong decoder na to, di ba yung ating if you can recall kanina, ayan. So pagka 0, 0, 0, etong D0 ang nagwa-1. Tama? So etong D0, pwede ang function ko dito is A prime, B prime, C prime. Bakit? Itong output na D0, nagwa-1 lang siya dito sa combination na to. So A prime, B prime, C prime. Eh yung D1 na output, saan lang siya nag-logic 1? Sa 0, 0, 1 lang na input. So I can make an expression or a term for D1 that is A prime, B prime, C. Tama? And so on. A prime, B, C prime, and so on. So, if now that we established na yun yung term ng bawat output, we can already put this into our circuit. So, hahanapin lang natin asan ba si minterm 1, minterm 3, minterm 5, and minterm 6. Okay, sabi natin, minterm 0 is nasa D0. Diba? Ito din yun, no? So, ito, this is, if in terms of minterms, this would be M0, M1, 2, 3, 4, 5, 6, 7. Tama? So, M0 is, ayan. And so on. So, pwede ko rin palang sabihin na pagka ang nabanggit niya dito, minterm 1, that is D1. Diba? Minterm 3, that is D3. Minterm 5, that is D5. And minterm 6, that is D6. Now, since we already know that, we can simply use a 3 to 8 decoder. And dahil ito ay naka-minterms, ang makukuha natin dito is SOP form. So, pagka SOP, sum of products, and ito naka-product terms na, so isasum na lang natin sila. Or a proper term is i-OR na lang natin sila. Hence, this OR gate. So, minterm 1, that is D1. Minterm 3, eto, D3. Then 4, D5, minterm 5, and D6. So now, we already have our implementation for this expression. Okay? So, I hope that is clear. Tinitingnan lang naman natin yung truth table, di ba? So, it will all boil down to the truth table. And how are we going to interpret that truth table? Okay? So, isa pa. How about naman ito? Pwede pala, no? We're gonna use a decoder IC to implement a full adder circuit. So, naaalala niyo pa ba ito, yung full adder? Hindi na. So, full adder is an adder that generates sum and carry output as well as yung input niya has carry over. Diba? So kung maaalala nyo, yung expression for the sum and the what they call this, the carry output are this. Ito yung nakuha natin sa previous discussions natin. And as you also know, or as you can recall, our circuit for a full adder is ito. Tama? So this is ito yung dalawang bits na ina-add natin. And then we have the sum, carry output, and this is the carry over galing sa previous. Tama? So this is a full adder. It's composed of dalawang half adder. Okay? Now how are we gonna design this? So ang gagawin natin dito is hanapin ulit natin yung mga minterms. Dahil naka-SOP naman ito, so hindi tayo masyadong mahihirapan maghanap ng minterms. Mapapansin nyo si S is naka-standard SOP form na siya. Ayan. So we don't need to make an extra step to convert this to the standard format. So what is the standard format? Since ang input natin is 3 variables, A, B, and X, therefore, to make it into a standard format, each term should contain each variable. So this first term contains A, B, and X. Second term contains A, B, tsaka X. Third term contains A, B, tsaka X. And the last term contains A, B, and X. So therefore, this is already a standard SOP form. Now, the question here will be for carry output. It is not in its standard form. So we have to convert this. How are we gonna do that? We simply multiply it by i-AND natin siya sa OR ng variable na kulang sa variable na kulang na naka-OR sa complement node. Bakit? Parang iano natin siya di ba? X na naka-OR sa Y or Y prime. Y or Y prime, this is simply 1. Tama? So this is equal to X lang din naman, di ba? Pero kung i-distribute ko to, XY or XY prime, this is the same. It's also equal to X. But in this format, kita natin, each term contains each variable. That's what we're gonna do here. Okay, so sige, gawin natin. For C, that is BX. So kulang siya ng A. So ang gagawin natin dito is, i-AND natin siya sa A or A prime. Basically, that is like ANDing it to 1. Kasi A or A prime, that is always equal to 1. So this expression will still be equal to BX. And then, next is AX naman. Ang kulang niya is B. So i-AND natin siya sa B or B prime. Tama? And then, the last expression is AB. I-AND natin siya sa X or X prime. Okay, now we have this. We have to distribute it. This will be ABX or sa A prime BX. Or sa, ito naman ay ABX. And then dito, or sa A B prime X. And then next is ABX. Naka-OR sa ABX prime. Ayun, nawala na tayo. Ayan. Okay. Now, we can see here common terms, ABX, ABX, saka ABX. When we say X or X, that is simply equal to X. Tama? So, itong tatlong ito will simply be A, B, X. Ka-OR sa wala nang ibang common, di ba? Ito A prime, BX, naka-OR sa, this one is A, B prime X, naka-OR sa AB, X prime. Ayun. So, mayroon na tayong standard SOP form for our carry output. Now, since we already have these two, we can implement it na. So, again, since tatlo yung variable natin, we're gonna use a 3 to 8 decoder. Okay? So, kung what do you call this? Kung i-translate natin ito sa truth table, so we have the A, B, and X. So we have 0, 0, 0, 0, 0, 1. So bilisan ko na lang. 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1. So yan yun. And then our S will be, nasaan siya? Nasa 0, 0, 1, 0, 1, 0, 1, 1, 1, tsaka 1, 0, 0. So 0, 0, 1, ito yun. 0, 1, 0, 1, 1, 1, tsaka 1, 0, 0. Ayan. And then yung C natin, nasaan naman yung C? 1, 1, 1, 0, 1, 1, 1, 0, 1, tsaka 1, 1, 0. So, hanapin natin siya. Sige. 1, 1, 1, 1, 1, 0, 1, 0, 1. Tama? And then 0, 1, 1. Ito. Ayan. So, the rest ay 0 na. Okay, so hahanapin natin siya. We already know that D0 is min term 1 and D7 is min term 7. Na-establish na natin to kanina. So hahanapin natin to. Kailan sila nag-1. So for S, so palitan lang natin ng kulay. This would be 0, 1, 2, 3, 4, 5, 6, 7. There. For S, kailan siya nag-1? Sa min term 1, 2, 4, tsaka 7. Okay, so si S pala is 1, 2, 4, 7. Okay, so tingnan natin. Ito si 1, 2, ayan, naka-OR. 4 and 7. So, okay na to si S. How about si C? C naman, ang min terms niya ay ito, 3, 5, 6, 7. So, this is 3, 5, 6, 7. So, as you can see here, 3, 5, 6, 7. So, okay na din si C. Now, we have a full adder using a decoder. Okay. So, I hope malinaw siya for you. That is our decoder. There are still so many applications for decoders, but let's focus here muna yung madadali. Okay, you can check this out dun sa ating reference book. Ang maganda ang pagkaka-discuss nun, it's detailed and talagang yung applications are actually good. Okay, now let's move on to encoders. Decoders are encoders, baliktaran lang naman ito. So encoders will perform the reverse of our decoders. Kanina, we have an n input lines and a 2 raised to n output lines. Dito naman, baliktad. We have a 2 raised to n inputs and n output lines. Okay, in this example, this is an example of 8 input, 3 output decoder. This is 8 to 3 encoder. This encoder assumes that only one input line is activated to logic 1 at any particular time. You can have encoders that have more than one logic 1 in its input lines. Okay? Out of these 256 combinations, only 8 are useful, and the rest are don't care conditions for this encoder. So ang daming kasi nitong combinations na magagawa natin, di ba? Biruin mo, that is 8 na input lines. So that will give us 256 input combinations. So for this example, we are going to assume that isang input lang ang pwedeng mag-logic high. Okay, so mapapansin nyo dito sa first line natin, D sub 0 lang yung nag-1, and then the rest is 0. But then again, this is not a limit for encoders. You actually have 256 combinations for this type of encoder. And you can utilize all those 256 combinations. Okay, but for this, to study the encoder logic circuit, we're gonna be making those other output or input combinations as don't care conditions. Magpo-focus lang tayo dito. Okay, na paisa-isa lang yung naglo-logic 1. Okay, so this is our the encoder. So baliktad naman siya. Pagka 0 lahat, ang mangyayari, yung ating output will be 0, 0, 0. Tama? Kanina, sa decoder, pag 0, 0, 0 yung input, ang lalabas is si D0 lang yung maglo-logic 1. Pag 0, 0, 1 yung input, si D1 naman yung maglo-logic 1. Dito baliktad. Okay, so talagang i-reverse na lang yung function kanina. Pagka si D0 yung nag-1, automatic merong code for that, and that would be 0, 0, 0. Pag si D1 nag-high and the rest is 0, automatic there's a code for that. That would be a 0, 0, 1 code. Okay? So, yun.